Okay, so we're going to start by going through what we went through yesterday. Make sure that we're still good. If you have questions, ask. If you didn't get notes, get them copied down. The chart on page 330 is the exact same stuff, but it has shorter versions of the names, so you might want to copy those names down next to what you took notes on yesterday. Okay? So real quick, if we have same bases multiplied together, what do we do with the powers? We add them. When you have a power to a power, what do you do with the powers? You multiply the powers, keep the base. All right, when you have a power outside with two bases, the power gets distributed onto which base? All of them, right? So if I have 5 bases inside with a power outside, the power winds up on all 5 bases, correct? A negative power means that we change the location of the base. All right, did we get here yesterday, or is this? Okay, just making sure, thank you. So a negative exponent is not allowed mathematically. It is improper, kind of like having a decimal in a fraction, which they both mean divide, so we're not allowed that. A negative exponent just means that we turn it into a fraction, and we put the base in the denominator. Okay, so if you notice, here we have a negative exponent in the numerator position. So when we're done, the base will end up in the denominator position. A negative exponent in the denominator position means that the base will, in fact, wind up in the numerator position. Okay, so the negative exponent is kind of like a negative in the radical, right? We use an I to replace that negative. When we have a negative exponent, we change the location of the base from either numerator to denominator or denominator to numerator. Power will become a positive, okay? Not equal to 0, correct. Because what's 0 to any power? 0, and can you divide by 0? No. So you're not allowed to do this. So if you have like 0 to the negative 5th, that's just 0. That is not 1 over 0, which is undefined. That's what they mean by A not equal to 0 here. Okay, so let's take a look at a few examples real quick. They say x is equal to a negative 6, where x is in the numerator position because you put it over 1 to write it as a fraction. So a negative exponent in the numerator means that base ends up where? In the denominator, right? So we convert this into a fraction of 1 over x to the 6th, where the power is positive because we change the location of the base. Okay, if you take a look at the second example here, what are the two bases we have? We have 5 and m to the negative 4th, right? What's the power on 5? 1. Is that positive or negative? Okay, so is the 5 going to change its location? No. So if it's currently in the numerator position, it will stay in the numerator position when we get to an answer. Is everybody okay with that? Okay, m, is the power positive or negative? It's negative, so it's going to go from a numerator position to a denominator position in the basement, right? So the m goes downstairs as a positive power because we changed its location. Yes?
And maybe the original equation was like 5 was the numerator and the negative 4 is the denominator. Would that become a numerator also and that become positive?
Like that?
Yeah.
Yeah. So the power on 5 is positive, so it stays where it's at. If you have a negative in the denominator, the negative means it changes location. So what's the opposite of a denominator position? A numerator. So the m to the negative 4th is going to become an m to the 4th as a numerator. So all the negative really means is you change its location from either upstairs to downstairs or downstairs to upstairs. Nope, because if you have m to the negative 4th 5 like that, right, where these are multiplied together, you still have these as distinct bases. So seeing that we move a base at a time, is the power on m positive or negative? Negative, so it's going to go downstairs into the basement. What's the power on 5? Positive, so it stays in the numerator position. And we get the exact same answer. Okay? So because we're moving by base, the only thing that determines location is the exponent on that base, not the order in which it's written. If this is a positive for here, then it can't change location. So this, if we had just 5m to the 4th, like that, okay, the power on 5 is 1, so it's a positive, so it's not going to change its location. And the power on m is 4, which is a positive, which means it's not going to change its location either. So there's nothing I can do with the 5, and there's nothing I can do with the m, so this is actually simplified. Okay? So the property only deals with when we have a negative power. Okay? Any questions on that? Yes, no, maybe? All right, so let's go through these real quick. So y to the negative 12, negative exponent, yes or no? Which base is it on? Which base has the negative exponent? The y. Okay, so is this currently upstairs or downstairs? This is currently up in the numerator position, so where's it going to end up? Downstairs. So I get 1 over y to the 12th as a positive power. It's technically because we're dealing with the reciprocal, but either way you just said it is still correct. Okay? Because technically what's going on here is this is y over 1 to the negative 12th. And a negative exponent means that we take the reciprocal of the piece inside, so we get 1 over y to the 12th, which means 1 to the 12th over y to the 12th, which is 1 over y to the 12th. Technically, mathematically, that's what's happening. But we don't necessarily show you this just because it's a lot of work to get to the same spot that the property shows. But that's where the 1 is coming from, is it's actually the denominator of the y. So we're not creating it out of thin air. Okay, for 2, how many bases do we have? 3. We have a 4, an m, and an n, right? Okay, so the 4, does it have a positive or a negative exponent? Positive. So is it going to stay in the numerator position, or is it going to change to the denominator position? Stay. So on my numerator, I have a 4. What's the power on m? Negative. So is it going to end in the numerator or denominator position? Denominator. What's the power on n? Positive. So where does it end? On top in the numerator position. Nothing else can cancel from top to bottom, so we're done. So for 3, right, I have a 1, and then I have an s to the negative 1/4, or sorry, negative 4th. So the power on 1, is that positive or negative? Positive. So is the 1 going to stay top or bottom? It's going to stay on top. What about s to the negative 4th? What does a negative exponent do? Do we keep it in the position, or do we change its position? Change. So it's going to go from denominator to numerator. So it's going to go upstairs as a positive. And what's 1 times s to the 4th? S to the 4th. Okay? Any questions on that? So remember, a negative exponent means we change the location of the base, either from the numerator to the denominator or denominator to the numerator. Everybody all right? Okay. Same thing here, right? The 2, is it going to stay or change? It's going to stay. What about n? And what about m? It's going to move from the bottom up, right? So what's my final answer going to be? There you go. Now, if you write that in alphabetical order, which is what we tend to do when it comes to standard form, and you wrote 2m to the 8th times n, you're still right. Okay, order does not matter in multiplication, so I do not necessarily have a preference as to what order you write it in. Anything else on these 4 that you want to double check? Make sure of. All right. So when you divide, so when we multiplied same bases, what did we do with the exponents? When you have the same bases multiplied together, what do you do with the exponents? You add them. If we divide the bases, what do you think we're going to do with the exponents? Subtract. So a to the m over a to the n equals a to the m minus n. The only thing that's tricky here is we still have to have the exact same base from top to bottom, which is what the a's are all about. And real quick, does order matter when you subtract? 5 minus 3 is not the same thing as 3 minus 5. So order does matter. So if you notice, which exponent is in the lead in my division or my subtraction statement? M, which came from where? Numerator or denominator? The numerator. So now that we can handle negative exponents, we're not going to worry about them until the very last step. And whenever we divide same bases, we always take the top exponent minus the bottom exponent. Okay? So we always have to set that up as the exponent from the numerator minus the exponent from the denominator. So if you take a look here, for the example, do they have the same base? What is the base? X. So I get an X. What is the exponent from the numerator? 5. What is the exponent from the denominator? So we go 5 minus 3. Okay, so we have to make sure that we get that order correct. All right, so what's 5 minus 3? 2, and you get x squared. Everybody all right with the example, yes or no? So all I'm saying is that you notice that they have the same base, right? So we can use our property. And the property says m minus n, so we have to take the power from the numerator minus the power from the denominator. So we have to make sure that we set up the order properly. So we take 5 minus 3. Well, a lot of times you get so used to seeing the bigger power on top that some of you, your brain thinks, oh, I always put the biggest power first, and you don't. You put the power from the numerator first, and then the power from the denominator. Okay? Yeah. So if you get a negative exponent, we have the previous property, so we can get rid of it. So you cannot have a negative exponent in an answer. All right. So for number 1, do I have the same base on top and bottom? Yeah. So what is my repeated base? A. Okay. And what do I do with the powers? 11 minus 7. So power on top minus power on bottom. What is 11 minus 7? A to the 4th. Everybody okay? Okay. So what's m to the 4th over m? M to the 3rd. Now, does this property make sense to you guys or no? Okay, let me show you where it comes from a little bit. This one's easy because things are small. So what does m to the 4th really mean? M times m. Right, m times itself 4 times. So m to the 4th is equal to m times m times m times m. Everybody good? Yeah. All right, what is in the denominator? 1m. Okay, so what is anything divided by itself equal to? So what is m over m really going to do? They're going to what? They're going to cancel out. And what's anything divided by itself? 1. So what we're really doing is we're using the subtraction to cancel, right? I have 4 m's on top, 1 m on bottom. How many m's can cancel? 1. So how many are left on top? So I end up with m cubed, which is exactly what I got over there. So subtracting the powers is the exact same process as multiplying everything out, canceling off like terms, and then putting it all back together. So instead of making you do that, we saw the pattern and we record the pattern, and that's where these laws come from. So all of these laws are just simplification techniques that you've been using since 7th grade. We're just putting them together in a list. That's it. Okay? Everybody all right with that? Yes or no? All right. So number 3, how many bases do I have? 2. What are the bases? All right, so I've got x's, and I've got y's. So my answer is going to have x's and y's. So I move one base at a time. What is the power on x, what is the power on x in the numerator? 3. And then in the denominator, so I go 3 minus 1, right? What's the power on y in the numerator? And in the denominator, 2. Okay, so what's 3 minus 1? And 6 minus 2. So if you can jump here, that's cool. You do not need the intermediate step. If you don't need it, don't use it. Just be right. If you can go 3 minus 1 is 2, and 6 minus 2 is 4, and go from here to here, you're welcome to. Okay? So, number 4. Sure. Hang on. Give me 1 second to get set up here. Wait, I don't know how you're going to do it, so let me change that. Okay. What do you got? Perfect. So, for those of you playing at home, right? For P, we take 3 minus 5 and get P to the negative second. Again, we can't have a negative exponent. So that tells us that we're going to wind up with a fraction because we have a negative power. So it's going to wind up in the denominator. So I've got a P squared in the denominator. And then 8 minus 7 is 1. So that means that I have a Q to the first in the numerator. And I'm done. Yes, sir. No, you can just put Q. If you write just an X or just a variable, it's assumed that there's a power of 1 there. Okay, so you don't have to include it, but you're welcome to if you want. Once you get the laws down, it is. It's one of those things that if you have the laws, it's like, oh, okay, that's all we're doing. But if you don't have the laws, because you have to expand everything out, it gets pretty difficult just because it's a lot of writing. But that's why knowing these laws helps speed you up a lot. Okay, so we have 2 more properties. The first one is called the zero power property. And it's really simple. All it says is any base to the 0 power is 1 except for 0. This is the epsilon. This is a Greek epsilon. It means element of or part of the set. So A element, all real numbers, not equal to 0. So that means that A is all real numbers, not 0. Okay? This is how math actually looks. This is math talk when it comes to proofs. And it's a habit of mine. So that's why I put the A not equal to 0. Just use this. What's 0 to any power? 0. Okay, what's any A to a power of 0? 1. That's what this is saying. Any base to the power of 0 is 1, okay, unless the base is 0. 0 to 0 is 0. That's all this says. Any number to the 0 power is 1 unless the number is 0. So if this is confusing you, there we go. All right, so any A to a power of 0 equals 1 unless A is equal to 0. 5,284.736 to the 0 power is 1. Everybody good with that? Yeah? So the only trick is that anything to the 0 power is 1 unless the anything is a 0. 0 to the 0 is 0. How would you simplify this statement? Where do I start? Walk me through it. Okay, so what's the first thing I have to identify? My what? My bases. So what are the bases in play? P and Q. So I have a P base and I have a Q base. So over here in my answer, I know I'm going to have a P and I'm going to have a Q. So what am I doing with the P's? Am I adding them, subtracting them, multiplying them, or dividing them? What am I doing with the P's? We're dividing the P's, so I subtract the powers, right? So what's the power on top here? 1 minus 1, which is 0. So I get P to the 0. For my Q's, what's the power on top minus the power on bottom? Negative 1. Okay. So what's P to the 0 power? 1. So this is gone. I don't need it anymore. It's equal to 1. How do I handle Q to the negative first? 1 over Q. And you're done. Everybody all right? So this is how we actually use this property. So it's something that we use in evaluation. Okay? And it's something that you know and you've been using for a very long time. It's just that we haven't explicitly written it out. So this is like chapter 1 when we talked about the identity property, right? And any number times 1 is the number, and you guys know that, but you didn't know that it was called identity property. This is the same thing. You know that if anything cancels from top to bottom, it's equal to 1. This is the exact same thing. It's just that this is what it's technically called in mathematics. Everybody all right? One more property. Power of a quotient. And this is something that you already know how to do because we have the power of a product, right? Where it was the parentheses with A and B inside and M outside, and it became A to the M times B to the M. This is the exact same thing except it's division. Okay? So A over B to the M is equal to A to the M over B to the M. So it's the same thing. The power outside distributes onto every base inside the parentheses, top and bottom. Everybody good? All right, any major questions? Do you want to run through some examples of that, or are you okay? Pick a level, easy, medium, or hard. Okay. Okay, there you go. So, this looks big nasty, right? And some of you are looking at it, and your brain is feeling a little bit scared because it's so used to being trained to jump to an answer. And I've told you all year, you have to fight the urge of your brain jumping to an answer. You have to baby step and work through. So, over here, yeah, that's a negative 2. Over here, what was the first question I asked you to do? Identify the what's. Okay, so whenever we simplify, that's what we're going to do. So what are my distinct base types here? 5, X, Y, and Z. So all I do is I move through these one base at a time. Everybody okay? All right, so I'm going to start off inside. So I've got a 5. All right, look at my x, right? Do I have x's? Do I have more than one x? Okay, what's the operator between the two x's? Are they being added, subtracted, multiplied, or divided? Okay, the two x's are being divided, so what do I do with the powers? Subtract them. So I go top minus bottom, right? So what's 2 minus 4? So I get x to the negative second. My y, do I have any y's running around? Just the 1, right? So what's the power on y going to be? 1, right? What about my z? How many z's do I have? 1, but where is it, top or bottom? Bottom. So if I'm writing this statement in this fashion, is this a numerator or is this a denominator? That's a numerator. So how do I move a z with the positive 1 power from the bottom to the top? Make it a negative. I'm going to do it another way. All I said is that if z is currently in the denominator, but this is a numerator, how do I move z from the bottom to the top? You negate the power, right? Okay, so now, which pieces get this negative 2? All of them. So, I get 5 to the negative second, x to the fourth, y to the negative second, z to the second. Everybody all right with that? Yes or no? Okay, where does the negative power on 5 take it? Up or down? Down. So I get a 5 squared downstairs. X, up or down? Up. Y, up or down? Z, up or down? Up. Everybody all right so far? Okay, we're almost done. What's 5 squared? So we have to actually evaluate it. So we're going to get x to the fourth, x to the fourth, z squared, all over 25, y squared. And that's your final answer. So the important thing here is this power outside, is it positive or negative? Negative. Which pieces is it impacting? The numerator, the denominator, or both? Both. Okay, so if we negate the stuff inside, right? Where does the numerator end up with the negative power? Upstairs or downstairs? Downstairs. So we're taking the entire numerator and moving it to the denominator, right? What are we doing to the denominator? Moving it up to the numerator. What do we call that in math when we flip the numerator and denominator? The reciprocal. A negative exponent means that you take the reciprocal of the fraction and then you just multiply in the power of 2. Okay? So if I gave you something like 3/4 to the negative third, right? Instead of, you can move the negative 3 in and the negative 3 in and then change all the locations. Or if I see a negative exponent outside, what am I going to do to this fraction? Flip it and take the reciprocal. So I get 4/3 to the third, which becomes 4 to the third over 3 to the third, and 4 to the third is 64, and 9 to the third, or 3 to the third is 27. And that's your final answer. And it's that quick. Okay? Everybody all right with how that's going to build? Yes, no, maybe? So, I'm going to run through one from your homework so you know exactly how much information I want for you to get full points. I don't want anybody complaining going, but I didn't know I needed all that. We're going to fix that right now. And then I'm going to give you the homework assignment, okay? So, oh, shoot, scientific notation. All right. So, yeah, but it's not that bad. Yeah. No, actually, this isn't. I forgot I have to teach you guys scientific notation. In the past, I've assumed you kids know it, and we don't. So, I want to fix that this year. So, how does this relate to what we've just done? What do you see that looks familiar? Exponents. Okay, we have an exponent outside parentheses, right? So how many bases do I have inside the parentheses? 2. I have a 2.1 and a 10, right? So what am I going to do with that power outside? Which piece does it go to? Both. So I'm going to take a 2.1 to the third, and I'm going to have my 10 to the negative fourth to the third. Everybody okay? Okay, so use your calculators. What's 2.1 to the third? Do you guys know how to do the third on your calculators? Yep, you either use the chevron or caret button, or if your calculator is a Casio, you're going to be looking for the Y to the X button. So it's going to be Y to the X like that. Okay, so what's 2.1 to the third? 9.261. Everybody okay with that, yes or no? When you take a power to a power, what do you do with the powers? You multiply. So what's negative 4 times 3? Negative 12. And this is it. You're done. The only major rule with scientific notation is that the number up here, you're only allowed in one place. So what happens if you multiply out the whole numbers and you get something that is not less than 10? You have to move the decimal. And this is where things get super tricky, so please make sure you're following along. What is this actually equal to? If I asked you to expand this, how would you expand it? Who remembers? How do you expand scientific notation? Huh? Kind of, not add 6 zeros, but move the decimal 6 times which way? To the right. So, we're going to move this 6 times to the right. So, I started here, right? 1, 2, 3, 4, 5, 6. Everybody okay with that? Yes or no? Yes. And you learned it in chemistry and physical science. So, what's going on here is I need this to be equal to 1.8473 because I'm only allowed to have a single digit in front of my decimal. The question is, what power do I need on 10 so that this statement will be equal to this statement? Well, I'm here, right? Okay. If my decimal started here, and I have to add here or end here, how many spaces did I move? 7. Okay, what's weird about that is usually when we move a decimal to the left, it's when we have negative powers on 10, right? But I'm creating an extra space that I have to move my decimal when I expand. So it's kind of like, remember when we did horizontal shift, right? Your H, it always flips its sign, and H of a negative 2 means we actually move to the right. This is kind of similar. When we move the decimal 1 to the left, we actually add 1 to the power on 10. Everybody okay with that? Yes, no, maybe? Okay, so number 5, this is from your homework. So if I gave you this problem, and I said I want you to evaluate it, what I want you to do is I want you to use the power rules to simplify. That's one part. Use your calculator to evaluate your simplified answer. That's 2 parts. And then for the first set here, 3 through 14, you have to list which properties you're using. So that's 3 parts. So 3 through 14, I need 3 answers. So first things first, what do you notice about number 5? Do we have repeated bases or anything? Okay, what's the repeated base? Negative 5. You notice that they're in parentheses in both positions, right? That's important for us because that tells us that the negative is included. So they are, in fact, identical. If we had a negative 5 and a 5, I cannot combine them. Okay, the bases have to be identical. So when I have same bases multiplied together, what do I do with their powers? Add them. So what is 1 plus 4? 5. So this is one answer. This is our simplified answer. Okay? Now I need you to evaluate it. So plug it into your calculator. Parenthesis, negative 5, close parenthesis, caret 5. And what do you get? This is your second answer, and that is the evaluated answer. So remember, whenever the directions say evaluate, I want to see this. So this is evaluate. This is simplify. So remember what I've been saying all along, the different words mean different things, right? And that's why some of you would get problems wrong in Algebra 1. You do all the math right, but you wouldn't answer the question all the way. Or you would circle the wrong answer because you would circle the evaluate answer when it said simplify, or you'd only simplify when it said evaluate. So make sure that you understand what they're actually asking you to do. Okay? And then the last thing is which property did we use? So which property is that? The product of powers. So remember at the beginning of class, I told you to turn your book to page 300, or sorry, to 330. So if you turn to page 330, what do you see? The table with the names, right? So if it were me, I would go through my notes, and I would transfer those names over to the corresponding section in my notes, so that way I have them. Okay? Yes, ma'am. No, because there's a lot of repeats. If it's like a negative power, you can just put neg. Okay? You can try to abbreviate, but just be careful. Yeah, like if you put prod of power, that's fine. Okay? But because so many things repeat with the titles, there's like 2 or 3 POPs. I wouldn't know which one you're using. Okay? And real quick, some of you are up here going, Pitsley, I hate you right now. Why are you making us do extra work? I can just type this into my calculator and it'll spit this out. I know it will. But can your calculator handle variables? No. So that last problem we did, can your calculator handle something like this? If you type this into your calculator, is it going to spit out this answer? No, not at all. And it doesn't matter which calculator you have. Even a TI-89, because it assigns values to variables. So, if I let you just use your calculator for everything, in the first section, when you get to this section, you're going to be lost. Okay? So, I understand that when it comes to quizzes and tests, you can just type them in and jump here if I ask you to evaluate. That's cool. Okay? If I ask you to simplify, you need to use the properties. But I want you to get the practice now of working with small numbers and your properties, so that way when we get to big expressions using variables that are all over the place, you're not lost. You know what's going on. Because Chapter 8, which is solving and simplifying rational expressions, builds off of this, but instead of it having just a number, it's going to have like a quadratic or a cubic to a power. So you're going to have to know how all of this stuff works. Everybody good? All right, so please, 3 answers for the first set. Thank you.